maybe something like the spring balance. So this spring balance is easily available in any market. So you have something in grams, something in newtons, and you have a spring inside it, which if you pull would give me how much force is available. So if I pull this spring, so maybe I am now exerting 20 newtons force. So I have the strength of pulling it, and I'm just exerting about 20, 25. Oh, this is the maximum strength which I can pull on. So now this spring is going to help us, or this scale is going to help us give what the force is. Now in order to study coplanar forces, we'll consider this as one plane. This is just a drawing sheet which is placed on a drawing board, and we'll take 3 of these spring balances or spring scales. So I'll just fit one by one. So this is one which has been fitted here. This is the second one which is fitted here, and the third one which is already fitted here. Now I'll take some strings. I'll tie a knot at the center and try and hook these to the springs in over here. Now if you see in over here, now these readings are 0, 0. The moment I give slight tension to this and just hook it up with the second part, I'll be getting some readings over here from this particular spring, this spring, and the third spring. Now this is as far as general understanding is concerned. Now if I want to put it into practice and see what is the forces which are there. So now I want to understand the forces which are acting on this in these strings, which are directly shown in over here in terms of magnitude. So in this case it's 5.5 newtons, in this case it's 5.5 newtons, and in this case it's 8 newtons. Okay, now what we will do is we'll play a simple trick. We'll just insert a paper below these strings and maybe plot points so as to mark where the lines of force are acting. So what we'll do is we'll mark the center point first. So this is the center point which is marked in over here. Then along this line I'll mark another point which will indicate the force in this direction. Similarly, along this line I'll mark another point which is the force in this particular direction, and ultimately along this line I'll mark the third point which will just give me 4 points. One is the center point, the other one is force along this direction, force in this direction, and this direction. So I have got 4 points. Now based on these 4 points, now I can draw lines of these forces where they are acting. So this is the point from where these forces are emerging. So what I'll do is I'll just draw lines. It's a bit to a larger scale. So this is one. This is the second. Okay. Now what I'll do is, instead of drawing this particular line and its magnitude, I'll just write down only for these two forces what is the reading. So in this case it's 5.5 newtons. In this case also it's the same, 5.5 newtons. Now all of you have studied law of parallelogram. So what I'll do is we'll play a trick. In order to determine this force, what I'll do is I'll just draw a parallelogram in the normal style and maybe put it to scale. So it's 5.5, so 1 Newton I'll put it as say 1 centimeter. So 5.5 would be somewhere here. Similarly, and I'll draw a parallel line to it. Okay, I'll draw a parallel line to this. Similarly, I'll go at the other end. Check on whether this is 5.5. Yes, luckily it's 5.5 only. This is a force which I have to still extend further and draw a parallel line to it. So this is again 5.5. Put my set square at the other end. Okay. And draw a parallel line which will be just intersecting the other part. Now this is law of parallelogram. So I know this force. This is 5.5 newtons. This is 5.5 newtons. I am worried about the other force in this direction. So the other force has to be in this particular direction. Without seeing this, if I just draw a line, okay, if I just draw a line which is in the direction of this particular force, which I have not yet studied, then I'll be finding that this force, if you can see in over here, has to be 8 Newton. Now if you see in over here, you'll be finding that this force in over here is exactly 8 Newton. So this force on this side is 8 Newton. Now you can realize that if you are not knowing one force, in this case we are knowing all these three forces, but if at all you are not knowing one force, you are knowing two forces, you know its magnitude, which is 5.5 newtons, you know its direction, just scale it down and graphically mark 5.5 newtons in over here. Similarly, on this force you mark 5.5 newtons in over here, draw a parallelogram, and whatever the diagonal is there would indicate the direction of that particular force, and the length of the diagonal would directly give you the magnitude of that particular force. So law of parallelogram graphically can be studied in this particular fashion. You already have seen how to solve the problems mathematically, but graphically also you can solve this problem with the help of drawing the figures to the scale. So in short, this is the setup which tries and explains law of parallelogram of forces and tries to explain as to physically how you can make use of the law of parallelogram to find out different forces and to verify whether these forces are in proper manner. Okay, thank you.